Welcome to the Untangling Web3 podcast. In this episode today, we'll be diving into the world of robotics finally, not as sci-fi characters, but as real machines already shaping how we work, live, and interact. We'll trace their journey from Isaac Asimov's imagination to today's global rollout as we see governments and tech giants pouring billions into robotic development. So what happens when robots become co-workers, caregivers, or even companions? Let's find out. Jack, you excited for this one?
Yeah, I'm excited. I'm a little bit daunted by it as well. Full disclosure, this is going to be the episode where I'm very much the layman in the conversation because Alec, it's your baby, right? You love robotics. You've got a background in it, and I don't know a whole lot beyond the sci-fi. What you see in the movies and books and things. So it's going to be interesting. I think I'm going to learn a lot, hopefully, and you're gonna teach me, right?
Yeah, I mean, I think I love this work. I love this topic. I love this area, and I think that so many laymen's also do because it's very accessible. Like when you talk to even a software developer, it's very abstract. When you talk to someone who's not in software about software, it's even more abstract. But robotics, it's so physical. Everyone can
Mm.
kind of understand the value proposition immediately and is either horrified or glorified or, whatever kind of thinks of it in a positive light or a dystopian light. So I think, yeah, this is going to be something that resonates with a lot of people anyway, the topic, whether you hate it or love it. But the fact that you said that, your only knowledge maybe is the sci-fi novels that you've read is super important because I think that is kind of the defining the art of possible. And I think so many roboticists, like me included, read the early novels like Isaac Asimov's work, and that inspired them. And you see so much of like what people are pushing towards today being based from those novels, and it's kind of like a self-fulfilling prophecy, which I think is really interesting. And that's why I think it's one of those things where we have to start at the beginning to kind of talk about the origins of the word, talk about some of the early literature, and then we'll go into what's actually happening today.
Yeah, we're going to start this way back in the beginning, right? Like ancient history type stuff. Go back to the real theoretical history. So yeah, I'm excited for you to take me through this.
This is like a proper kid dressing himself for school, where it's like, this is like my two favorite topics is robotics
Yeah.
combined with a bit of ancient Greek history. Like I am
Okay.
like a kid in the playground right now. So if we go back, set your mind back, 2,500 years or something like that, like
Okay.
long before robots were built, we imagined them. And I think even if you go back to like ancient Greek literature, the idea of Hephaestus, this god of blacksmiths, building this giant, effectively automata or robot called Talos. And, I think it's quite weird that we kind of describe this as a robot because so many ancient cultures would talk about, kind of organisms or creatures that were made from stone or made from greenery and made from trees and all this kind of stuff. But there's something very distinctive about making things from metal. And I think it's the fact that it's kind of inorganic and it's kind of
Mm.
like seems like a human creation. And there's kind of like an immediate affinity to there being something different about creating a creature or a thing out of metal because we have this kind of affinity of metal being this man-made substance that isn't naturally occurring and maybe has like unique and magical properties because of that.
Yeah, it's interesting that what you kind of saying here is the one of the origins of the kind of concept being kind of related to the Greek gods, right? Because I think a lot of people see robotics as being humans playing God, right? It's almost like we're trying to create things ourselves now that are as much in our own image as possible. So it's interesting that it does tie back to the Greek gods. I mean, what do you know anything about like the kind of reception of that concept? Like, was it in like a kind of religious sphere, or is it
Mm.
intended? Like, what's the I guess what's the impression of this this early idea that was coming out?
My understanding is that it comes from like a lot of early cultures derive it individually. It's not like there's one source
Mm,
and that kind of spans out to everything. It happens in a lot of places. And I think like the link is kind of to what I said earlier, where, imagine being a primitive human like 3,000 years ago or something like this.
it's not that
And
hard
so
for me
much,
to imagine.
so much of the world, just go to rural Wales and you'll get it. So much of the world is like organic and it's there. But then metal is this thing that seemingly we created for ourselves and
Mm,
is associated with so many kind of distinct properties and characteristics because of that. A lot of people associated metal with like magic like properties or kind of things beyond like the normal realm. And I think that like the association of also being like godlike and like hubris and all these things about, you know, the more technologically advanced you are, the more powerful you are, the closer to God you are, and all this kind of stuff. So I think there's kind of two distinct camps early on, that metal is this special thing, and the idea of creating something in one's own image in the same way a lot of religions believe God did, creating something in one's own image but maybe superior or better, like made out of metal, because we can craft metal. We can't necessarily like freely craft organic material in the same way. It's quite unique. But then the other side is like the idea of hubris and like, you know, one's own creatures kind of destroying the person and things like that. And I think that often comes up in literature as well.
Yeah, it's interesting. It's like it's tied to the idea of technology and its superiority. Like, because obviously we're always looking to mechanical means almost, or physical means to help us achieve better results, right? Like, you know, as kind of you show me in the research, like ancient Egypt, you have things like hydraulics and pneumatics being initially designed, right? So ways we can harness the physical world to do things we couldn't do before. So yeah, and that the marriage of technology and deism and like gods and things is, I think there's a lot of echoes of it today as well. Like, a lot of people treat the big tech giants as and the founders and CEOs as kind of the gods of capitalism now. So it's interesting that it goes back there.
And we're definitely going to get to that. And I think like, so there's that one idea of like this kind of humanoid type thing that's been manufactured as not human. And then the other things that you mentioned there is the idea of like tools and automation. Like, there's an obvious desire early on across almost every culture to create and advance tools. And on the one hand, to like be an extension of a human, like, you know, spears, bows, all this kind of stuff. But on the other hand, also to automate and maybe replace certain functionality. And that happens very, very early on. You mentioned there in like ancient Egypt, they used hydraulics and pneumatics to open doors. They did in the Temple of Thebes. This happened in early Indian culture and early Chinese culture. The idea of automating processes and enhancing processes using hydraulics. And all of that, you kind of saying, is like part of the origin story of like robotics, machines, like the development of this kind of like field early on. One of the things that we have to really mention is Al-Jazari, who was an individual from Mesopotamia in, I think it's like 1000, around 1200, 1300, something like this. And that was one of the earliest published books that really related to the idea of like automation, robotics. And in that, he created like basically 100 different mechanical inventions. Like, a lot of them would just theorize and, you know, kind of like Da Vinci style, where just thought about a lot of different things and wrote them on paper. But the idea of like robot musicians, drink serving automations, water powered clocks, some of them he did actually create, and like using like smart camshafts and valves to create these automated machines, which at the time were like magic to a lot of people, but now are kind of quite widely understood. I think that the main point that I want to capture in all this is that the ancient world gave us the idea of robots, like kind of not as enemies, but as tools and like magical servants that could kind of go beyond what we could do early on.
Yeah, and so basically ways of replacing things that either replacing things that were being done by humans before, and, you know, often through, I guess, things like slavery, probably, right, for building lots of early things, and the other field being how you can achieve things that you couldn't do before, right? I think that's kind of the main strands of how that links to robotics in my head. Then
I'm glad you use that word, and maybe that's like a nice inroad to the next bit. So moving away from like ancient history and literature to like more modern literature that again inspires a lot of the work that roboticists do. You talked about you mentioned slavery there, and the term robot was actually first used. It's a Czech word from the word robota, which actually means forced labor. So in a way, like slavery,
oh
like
wow,
you kind
okay,
of mentioned there, and
yeah,
that comes from Karel Čapek. It's a play by Karel Čapek, and in the play, this was in like 1920. Basically, a play about robots that are these synthetic biological beings built to serve humans, but eventually they, you know, rebel and wipe out like humankind. And this kind of like was very popular, very widespread, sparked early debates about the themes of automation, anxiety around automation, like the loss of jobs, control humanity. So the very things that, you know, are actually happening right now, 100 years ago, they were very much having the conversation. And this portrayed the topic of robotics and automation in a really negative light to the general public.
okay. Yeah, that's interesting. I didn't realize that it actually came from that. So yeah, I'm glad I kind of brought that up as a topic. I think yeah, it sounds to me like you, because we just jumped from 2,500 years ago to like the 1900s, right? And it seems like there's been a pathway for what, eventually will come to define like what we think robotics is now. But this idea of automating labor or automating tasks that we couldn't do before, and it for a long time that's a fairly purely beneficial thing from what I can gather. And it's kind of, this is just taking us on a better path. We can have the technological enlightenment, we can do things we couldn't do before, etc. And then you hit kind of the 1900s and on, and all of a sudden it's almost getting too good, and people start getting worried about, I guess, them being replaced, how we coexist in society when technology goes so far and starts mimicking kind of human behaviors that weren't just kind of simple mechanical tasks, but other kind of as we're alluding to AI already as well, right? But that kind of thing, that kind of fear we have around AI, it sounds like there's a similar one here.
Yeah, definitely. I think like it also correlates to like the kind of geopolitical shifts, like when you have like widespread large cities with, relative poverty and all this kind of stuff, and maybe job competition that didn't really exist 4,000 years ago, where there was always a place to do something. But like I say, bit of a negative turn, one of the most, like the first negative turns on this stuff. I imagine there was previously about, witchcraft and, kind of crazy people talking about, oh, what is this stuff? Burn the witch, the one building like that valve over there. And then one of the most iconic book series ever created that I am an absolute fanboy over. Have you read this? Isaac Asimov's The Robotics trilogy, the Foundation trilogy. Have you read the whole series?
I haven't read the series, Alec. I know Isaac Asimov, so this is a point where I do. There's something I know about this, but yeah, I know the name. I know the laws of robotics, the three kind of famous ones. Shamefully, probably more through something like iRobot than anything else. I think that's the one where I first came across the term. But obviously, like, yeah, he's one of the big three science fiction writers of all time. Has inspired. I mean, you could argue his work has inspired virtually everything we now see to do with robotics, from like the Terminator to uh, even like people like Philip K. Dick, and Electric Dreams, that kind of stuff that we see more recently. I think Asimov is also Foundation, right, which I think has recently been turned into a popular series. So yeah, his thoughts are like still very, very pervasive in culture now.
To think that he came up with this, like a lot of these concepts in the 1940s is mind
Yeah,
blowing. Like the idea of like early kind of robotic governance principles, like that hadn't really been thought of before. There was no such thing as robotics, not even robotic arms or anything like this. And he was thinking about like humanoid robots, but far like beyond that. He was thinking about the kind of like the political, cultural shifts that would happen in societies as humanoid robots started to become widespread. And honestly, I would recommend absolutely everyone read this entire book series. It goes from like the iRobot series to the Empire series to the Foundation series, and all of them are just sort of giant continuum that all spawn with the start of like the introduction of robotics and like how they're designed, how they're programmed, how these three very distinct laws, which I think are really powerful and should be mentioned. He basically came up with these three laws of robotics that were like the ideal ways of governing robots. And the first law, the most important and paramount law, is a robot may not harm a human. Okay. And then the second law is it must obey unless that conflicts the first law. So it must obey human orders unless that conflicts with harming a human. And then the third and final law is it must protect itself unless that conflicts with the first two laws. And like you kind of say, that sounds obvious, really easy to live by, but like there's so many things, like it goes into like real depth on what is harm to a human. Like, should I lie to a human or say no to it if it can cause emotional damage to that human? And the whole book series has a really great kind of consideration interplay of what it is to kind of define these laws of robotics and how there's interplay between them for any given situation. It is really fascinating.
Yeah, this is really interesting, right? Because I mean, you and I are quite big into the whole free will debate and morality and how we derive that. And I think this is somewhere where people are worried in some sense that a robot could take these laws and interpret the state of the universe in such a way that decides maybe kill all humans, right? It's like
Yeah,
if
a
it
paperclip book or whatever it was.
yeah, and if it perceives, for example, that the death of all humanity would actually be the minimization of suffering, right? That's kind of one way of defining morality. Then maybe it could interpret those laws as a reason to kill everyone and go Terminator, right? That's interesting. I also wanted to ask you, as someone who's read the books, then what
How does it
these
end?
yeah, we're finding out now, I think. But no, I think I wanted to ask that you call them laws of robotics. Are they like a didact on how, like, what's the law applying to? Is it a law for that you should abide by when you're building a
Mm.
robot? Is that the idea, or is it something kind of
Yeah.
more
So
abstract?
it's like basically they have when they start to create more humanoid robots that kind of go beyond typical processors. They're called positronic brains. And it's basically the laws are defined such that any manufactured positronic brain has to abide by these laws for it to be considered safe. There is basically
Okay.
like early robotics, as we're kind of seeing now, was starting to be widespread, and there was a general kind of resistance to it by humanity, by Earth at the time. And
Mm.
these were the kind of requirements that were entrenched into these positronic brains, these robotic brains, basically, so that they could kind of coexist with humanity in a way, or could be developed safely. But I think the really interesting things is like, it's not hard laws in such a way that's like, okay, well, what are the laws are there? Obviously, there's other dynamics, like these three laws won't answer any question that a robot has and then, define an
Yeah.
action. It's kind of, they're the overarching governance mechanisms. And it's like every decision made should try and feed into those three laws by order of preference. But like we say, a really, you can have a weighting between each of them, right? Like a really solid
Yeah.
order and we're not going to go too much into that. I
No.
find it fascinating, but we're not going to go too much into that. But the main thing I want to say about this is, read the series. It's incredibly
Yeah.
insightful from something written 100 years ago. And I think we're now coming into the realm where we're seeing humanoid robots being built, being deployed. And when they're starting to interact in like the general public, there will be questions around like, what is the governance mechanisms behind this? And do we need, widely adopted standards? And you are right. Like, so much of this feeds into like pop culture. Like you talked about Terminator, like obviously Blade Runner was another one. Like there's so many references
Yeah.
to robotics, advanced humanoid robotics in modern sci-fi because of Isaac Asimov.
Yeah, well, and I was gonna say the other thing that really interests me about this is actually the timing of it, and so we're talking like 1940s for a lot of this, and it sounds like it's at this point in time. Like, bear in mind, we don't really have computers yet, right? At this point in time, Alan Turing is still in the midst of cracking the Enigma code, right? And we
Yeah.
don't have computers yet. People are writing about how to program logic in humanoid robots. So that whole path from automating technologies to help simple tasks, as we talked about thousands of years ago, then by this point we've already jumped to humanoid robots, which is clearly way down the line. Like, we still haven't quite achieved that yet, but this was clearly the worry in 1940s while computing was being invented in parallel. It's just fascinating.
I don't know what he was on or how he managed to, like, I imagine it's like one of like survivor bias, where there was a million people that were writing absolutely nonsensical things, and Isaac
Yeah.
Asimov
Yeah.
just happened to be the 1 in 1 million that was on target. But yeah, like, I think that's all I want to say about the literature. I think the kind of the tone that I want to set, or the image I want to set for this, is there's been so much written, like from a kind of creative perspective up until the 1940s, that has impacted so much of the work after that. So much of the actual
Mm.
technology being developed has been influenced by these early creatives thinking about the art of possible purely from a creative perspective. And it's kind of like a self-fulfilling prophecy, where now we are, obviously humanoid robots are now being developed by multiple companies, and maybe a lot of these people have probably been like inspired by the work of Isaac Asimov. Today's episode is sponsored by the VChain Foundation.
Now, we often talk about how emerging technologies like blockchain have the potential to revolutionize sustainability, and VChain is at the forefront of this green movement with initiatives like VBetterDAO. Let's take a closer look.
Imagine tracking small actions, like recycling, at low cost, making them valuable assets. These verified records build a massive collective impact, benefiting people through their own actions. Sound a bit complex, but VChain made it fun. Explore our apps at vbetter.com.
VChain's goal is to power a new era of sustainable solutions. So if you've got an app idea or just want to earn rewards for small, sustainable actions every day, go check out vbetterdao.com to find out more. And now, back to the show. So let's move away from the literature. We're a tech podcast. Let's get into the tech. Maybe there's a bit of an inroad before we really do get into tech. We kind of need to set the foundation of like what was foundation series of references, too many references here, of like what was actually happening in workplaces before then. So in around 1913, we had this magnificent individual, Henry Ford, who kind of like set the gold standard of the assembly line. And though Henry Ford wasn't a robot, like the point was that he was moving practices to assembly line style culture, which enabled like mass production and repeatable kind of tasks consistently. That was kind of like the gold standard for producing on like a hugely productive scale. And these kind of like very routine, repetitive jobs were perfect in the early days for early robots. Like the assembly lines were perfect for early simple robots to operate in a control setting. It was because of Henry Ford that we had these principles that were widely adopted that enabled robots to make such an immediate impact when they did.
Yeah, and I think so obviously this is still okay, we've gone from theory to practical now, and at this point in time, like the early 1900s, the practical limits were, mechanizing simple tasks. So we've had the Industrial Revolution, we've had essentially electrified or gas powered systems in place to automate human work already. And then Henry Ford of Ford, just in case anyone is thinking about that name, it is of the Ford Motor Company. But he basically decided to he was looking at efficiency, right, and how what's the most efficient way to produce things en masse. He was producing cars en masse. So but my question on that to you would be, so would that come under the definition of robotics, right? If we're just, even if we're not talking about these humanoid robots right now, we're talking about simply putting things that replace human labor in the production line. Does that qualify in kind of the larger definition we got?
So like a robot is typically, or robotic is typically defined as like a machine capable of sensing, processing, and acting. So it's like quite a simplistic view of the world, I guess. The early robots within, like, say, the assembly lines, like the very early robots, were typically just capable of actuating. And then eventually, like, it became time-based actuating, and then it eventually became like sensor-based actuated. So I think you probably would describe these more as like machines, like automatic machines or something like this. But again, like, these definitions are so like they're so gray and vague. Like, it's not really that useful to define things in this sense.
No.
But you are right. Like, it perfectly set the kind of the scene for these early robots. And there was some early like academic work around the kind of before the like actual mechanical systems were starting to be developed around like logic gates and the idea of how to kind of use logic gates to simulate feedback loops so that, if input, I can do output. And these kind of really laid the groundwork early on in like the cybernetics paper around the idea of control and how you'd start to control these machines when they're in the open world. But you are right. The biggest advent was in 1954, which was the first robotic arm patented by a guy called George Devil in America. And it kind of
Devil spelled Devol, just for clarity, right?
Exactly. It kind of like, it was really simplistic. You can see images of it online, and it just looks like kind of 1 to 2 axis robotic arm, super old school. It used a magnetic drum to store task instructions, and it kind of was just a repetitive machine, not much intelligence, not much input, and it could just do things. But already people started to see there was a huge impact from that. And they started a robotics company 2 years later. It was called the Unimation Foundation or something like that. And there was another person called Joseph Elgerberger. I assume that's how you say it. Who was described, Engelberger. Let's go with Engelberger, who was described as the father of robotics. And they commercialized that early robotic arm into the Unimate robot. And this started to be widely adopted on those kind of factory lines we were talking about, initially at General Motors. And you, like, say, all the benefits that you were reaping from, those factory lines, those automated factory lines that Ford had originally kind of conceived of and pushed, were now having robots on them to really take that to the next level.
Yeah, and I think it's interesting that this is still a pretty recent development, but it's now the standard, right? Like, if you go into, I went in on a school trip to the Jaguar Land Rover factory in
every young kid in the UK did.
Exactly. And that's actually probably the only time in my life I've been exposed to robotics, because at that point, you walk around the factory, everything is being done pretty much by these big robotic arms, specialized for jobs, and some of them are big, some of them are small because they're doing different things. But we actually got, we spent time sitting down trying to program a very small version of one of these. That's part of one of the exercises, and it's fascinating because it's like, it's something that is quite simplistic in its original form, like in the kind of 1950s, but now they're incredibly articulate, right? They can be articulated in many different ways. They can do lots of different things, and they're now a bedrock in the manufacturing industry. I'm pretty sure I read as well that Amazon was produced. They have like a Amazon healthcare line, and
Mm.
they were removing pill packing into a robotic arms thing, right? So they basically were having pills put in bottles by robotic arms, right? Because it was just infinitely faster than how they were
Yeah.
doing it before, which is, it's kind of mind blowing, but also makes complete sense given what you just said.
Yeah, I mean, even in the early days, like they were seeing a lot of those benefits. Like they were typically used in quite dangerous settings where there was like hot metals or dyes and things like we didn't want a human in the loop.
Yeah.
So it's typically to do, repetitive, simple tasks, but dangerous tasks with precision. And obviously, like the upside was, worker safety. No one was involved in that. They could do 24/7 typically, but they were extremely simple machines. Like they were all electronically controlled, so there wasn't any programming where you could change things around. There was no perception, like I said before, no autonomy, no sensors. So like it's really important to highlight that these didn't have any environmental awareness. In like if we were to describe it, you're like a blind person who's deaf and can't, you're going top left to bottom right constantly. That's all you're doing, and that's all you know. You don't really understand anything around it. And they were powered mostly by like hydraulic actuators and all this kind of stuff. But if you move like basically 20 to 30 years into the future, because I see Jack's itching to push this forward, we get to 1985 and these kind of principles are just being pushed further and further, and like the actuators are becoming more efficient, they're becoming more powerful, they're becoming bigger, we're doing these on a larger scale, things are starting to be really productionized. And by 1985 you have 20,000 industrial robots in use in Japan alone, 4,000 in the US. And Japan really took hold of this like kind of manufacturing market in like the 60s, 70s, 80s, and became like basically the holy grail for robotic development, and especially on like manufacturing lines.
Interesting. I wonder. I don't know if you know, but like this sounds like maybe it was tied with the big Japanese economic bubble at the time, right? Because it seems like they were way ahead of things at that point. Do you know anything about that? Is that related?
Well, Japan really pushed it because they had massive labor shortages. So, like, they
Mm.
needed to kind of keep up in a manufacturing sense, but had huge labor shortages. There was like, they wanted to reduce reliance on foreign technology as well, and foreign immigrants and all this kind of stuff. So, they really tried to crack down the idea of, like, again, expanding what the current workforce could do with automation. And like it wasn't just the kind of the manufacturing, the electronics. They also, well, across the globe, like a lot of other things were being pushed. The idea of like vision, sensing, like actually being able to start to like say take an input where I won't try and grab a vial here until I know there's a vial. And then it becomes a question is like, how can I know there's a vial? Is it like infrared? I can have like a vision system. Vision systems were quite like limited early on. So it would probably typically be like infrared, where it'd be like a line from one point to another. And if that line breaks, I assume a vial's crossed it. But we were starting to see the idea of like moving from a machine more to a robot, because you had this ability to sense and make a decision and do something based on that without a human in the loop.
Got it. So just to kind of recap, we've gone from, ignoring the kind of the very earliest theory, like the theoretical conceptual stuff. In the practical terms, we've gone from the early 1900s, Henry Ford, and we're talking more about machines at that point that can actuate, that can do something. Then as we move forward, we're then talking about being able to do more complex things, but also being built, pretty specific single purpose. And then now, as we reach the kind of 1980s, 1990s and onwards, we're getting to not only is there an output from these machines, they can also take much more complex inputs. They can sense. They have they're simulating perception by this point, right? Not just action.
Yeah.
I guess is
Yeah.
in human
I wouldn't
terms.
say, yeah, that's exactly it. Like, I wouldn't say simulating perception. They are perceiving. They are like getting stimulus from the real world and making a decision on it. Like a very simple example is like you say, you have a healthcare robot that is moving vials on a conveyor belt into certain packages. As the vial comes in, it sees if it's green. If it's green, it puts it into box green. If it's red, it puts it into box red. That to a degree is robotic. But all of a sudden, we're starting to say that this robot isn't just doing the same thing every single time. It has a degree of external stimulus, a degree of understanding of the environment, and it makes a decision on what action it should do based on that. It's still super limited, right? It's still like basically three data points. If red, go here. If green, go here. So it's not very complicated. So the kind of the difference between it being a machine and a robot still is quite like it's quite
It's a
limited.
spectrum, right? Yeah. And I
Exactly,
guess
it's a spectrum.
at this point, we're still talking about like predominantly non-humanoid robots, right? So things that don't look like humans, and they're not exactly general purpose, like I guess a human brain is, that can be applied to virtually anything, right?
Yeah, like I think so. When we get into the 1990s, actually, them it kind of robotic arms are definitely the golden standard in manufacturing lines.
Hmm.
You're starting to see whole manufacturing lines basically dominated by giant robot arms that can obviously work 24/7, handle heavier weights, no danger to humans, all this kind of stuff. But in the 1990s, we're really starting to see the diversification of robots and the increase of intelligence. Like you're starting to see things like autonomous vehicles, so early kind of locomotion vehicles like little rovers and things like this, where they had sensors that can move around maps based on that. You start to have the Da Vinci robots, which is super interesting. I know a lot of people have probably heard of this, which is like early surgical robots. The idea of like, say, basically reducing tremors in an operator's kind of
Yeah,
hand, so they can like, you have like a joystick style thing. It wasn't like that early on, but it can reduce the amount of tremor and movement in the surgeon's hand. So that
yeah.
kind of feedback was pretty epic. And you started to see in the late 1990s early kind of bipedal walking and stair climbing human robots.
Wow,
So it
okay.
was like really in the late 1990s that we started to see the idea of like robotics starting to come into the humanoid sense. And bipedal locomotion is not a simple thing. So having like robots that
Doesn't
could do this
sound
in the
it.
19 even now you look at it like in
Yeah,
2024, like they don't really look entirely comfortable. I know we just saw like that humanoid robot do a marathon, but it didn't look like particularly stable or like
no.
efficient doing that.
Yeah, and I actually just as you were speaking, then I quickly Googled. I was like, well, I think that the example of robotics that most people will have seen in the real world or know of in the real world would be the Boston Dynamics ones, right? Like
Hmm.
the little walking dog, right? That's I guess that's quadrupedal, but
Yeah, yeah.
that was founded in 1992, which is really surprising to me. I presume that had been a much more recently founded company. So yeah, I guess these things were already starting by then.
And again, like it's not too complicated to have like a couple of motors that look like legs. Like they're not particularly functional, but they kind of
Mm,
look like legs. They don't work very effectively, but like it's fairly not simple, but you can do that. And you can imagine after like 30, 40 years of development of motors and basic robotics and basic control systems, that actually wasn't too big a leap. It's kind of like the widespread adoption we're seeing now and being able to handle things in like I guess non-controlled environments. That's the really impressive things. Having like dynamic control systems that can actually allow these to operate in the open world. But again, let's fast forward. So kind of we got to 2000, and like I said, 2000 plus, we're really starting to expand from static robots in place doing the same thing over and over again. They have their little context box and they know exactly what's in it and they just repeat tasks over and over again, to the idea of like moving around locomotion systems. So like robots moving in real world environments, dynamic environments with obstacles moving, people moving, terrain changes. And this is kind of like where it gets really tricky, because now all of a sudden it's not just about the robotic system and you have a
yeah.
defined environment, you select to go from point A to point B, it does that a million times. It is, I don't know what the environment's going to look like, but you've got to work out what it is and do something based on that. And this is like where it gets really quite interesting.
Yeah, this is just the part that kind of blows my mind, right? Because I imagine the technical challenge, it seems to the layman to be huge, right? And I guess other examples that people would be aware of, right? So the Mars rovers, that's a robot,
Mm.
right? Because it has the locomotion element that you're talking about. It has to move, has to be, I don't know. I guess I don't know how much of the Mars rovers was being effectively like remote control versus autonomously moving and autonomously doing stuff. I guess there's been lots of different ones on the way. But then if you think about autonomous movement, then the Roombas would be a really good example, right? Because the little discs that run around your house cleaning and vacuuming, they are obviously
Mm.
making decisions because they're sensing the environment. They're kind of pinging between when it gets near a wall, it has to turn around. I don't know if it's doing anything more impressive under the hood. Like, do they try and like optimize to make sure they clean the whole floor? Like, is that a thing?
They do now. So they're now like
Okay.
obviously AI, everything's AI enhanced, but Rumble was one of the
Mm,
early AI enhanced machines. Like I think I'm glad you brought up the Mars rover. That's something that is probably most people are aware of, and there's been multiple versions of that, right? And the reason there is kind of obvious. Like it's so far away that to remote control that, the latency between what I'm
yeah.
seeing on the screen and what it's actually doing is 22 minutes or 10 minutes at closest approach
Oh
and
wow,
things like
yeah.
this. So there's no way for a human to be in the loop in that. So you kind of have to have a self-contained system where you say, you just go explore, don't go into a hole, try and explore as much as possible, don't do the same paths over and over again, go tell me what you see and send the footage back. And obviously one of the first really kind of mobile commercialized systems by far were the Rumbas. Like yeah, I freaking love them. I remember seeing some of the early Roombas. We had like a little project in my old place where we would basically program a Roomba and kind of like optimize the path planning for the Roomba, because it's such like an intuitive way to think about things. And now obviously they have like little sensors where they can know, how far is the distance there, and they get a rough understanding of what their map is, what their room is, and they can optimize cleaning patterns where it's like,
Wow. Okay.
I had someone walk through part 3 of my map the other day. I should probably focus on that first. And then, I did phase 2 really recently. So I'll just do phase 1 next. So it's not super complex, but like they are AI enhanced now, whatever that means, where it's like they'll optimize the coverage to ensure they're cleaning as effectively and efficiently as possible.
Yeah, that's really interesting. And I guess like the only thing I'd add here is that I think the Roomba is quite a nice showcase of when you have, of where we are in terms of the space of problems you can solve with a robot and how advanced they are. So Roombas have been around for like 20 years plus now. And as you said, it's got a simple, very well defined problem with clear constraints, right? You're cleaning a room, right? The room's not changing. Maybe the cat's running around. That's something to deal with. But like the task is fairly simple. And again, robotics as a field has managed to pretty much solve that problem very, very well for a long time. I guess it's when you get to more complex problems, when you don't have such a narrow field that you're applying it to, that's when things get a lot more complicated, right?
I think another point is like if something goes wrong and the Roomba bumps into
low
a
risk.
kid, it's fine. Like no one cares. So you're very content to push these out and mass manufacture
as long
them.
as they're not going too fast.
Exactly. If like an autonomous vehicle, like a Tesla, goes wrong, it kills someone. So it's like very different degrees of risk there as well. So like I say, this is one area for Locomotion, which is quite important. Like we'll track robotics, kind of like basically taking cars, which we think of as machines anyway, giving them a degree of intelligence and like letting them do things. The next one, the one I want to speak about then, is kind of like you kind of have this contrast and this kind of like, again, the idea of animal inspired robotics. Like we look at evolution and we see how efficient evolution is and how efficient so many animals are, and there's so much inspiration to be taken there when we design things, and we often do. That one of the next big areas of Locomotion is the idea of quadrupeds, the idea of like Boston Robotics, big dog. I think everyone's seen that. Like it looks kind of like a robot, kind of like a robot dog without a head. And early it was kind of designed for like military, terrain navigation, like reactive gate, all this kind of stuff. But more and more we're seeing like Spot, which is made in 2015, being used in kind of, again, like dangerous terrain, like things like construction settings, mining, police work, disaster inspections, quite a big one.
Yeah.
And again, like it's just about information gathering. You kind of want these systems to be able to go investigate an unknown environment and see what's going on to give information to the humans to then do something with it. But like, it's quite tricky to go up a staircase as, a robot control system or work in hazardous environments where there's fires, you can't really see, maybe there's smoke and things like that. So you have to have a lot of different sensors kind of inputting to make sure that they can do, the best with whatever environment they're in.
Yeah, it's interesting that you mentioned that it was potentially like military applications originally. I hadn't actually crossed my mind, but when you think about, I mean, that's obviously also been the inspiration for like a very, very well-known Black Mirror episode, right? For these robot dogs and what can go wrong when you arm them and do other things. And I that kind of reminded me that a really obvious category of robotics that is, a huge topic at the minute is drones, right? So not just the drones for taking a nice picture when you go on holiday, but military drones. Like warfare has completely changed now by thanks to robotics, right? And for better or worse, it's very hard to tell, but it's like you were saying, you're sending in robots now to go and do the dirty work of things that previously you'd have to use human labor for.
Yeah, drones is a big one. Like a lot of my work was previous on drones. Like even the DJIs that you see now that are widely adopted, like you think that you're controlling that drone 100%, but there is like they've got their own control system, their own sensors that are making your job as easy as possible, because there's wind stability. They're very difficult to control. So even when you think you're going forward and just pressing forward, like there's 100 different inputs going into that drone to make sure it does go forward and doesn't go left when the wind kicks in. And I think a lot of people don't realize this stuff is so much of robotics and control systems that are kind of directly kind of have existed because of the robotic field are in every, kind of every different aspect of life. We don't realize it just makes our life slightly simpler, like drone control, for example.
Yeah, that scares me a little bit, right? You're telling me now that my DJI it makes me feel like I'm in control, but actually it's in control. that's a bit.
And one
That's a
day it's
bit
going to
worrying
turn
thought.
around and get you. That's so drones obviously a big area for locomotion. Bipedal, we've talked about it. There's like, I think the kind of early it was Boston Dynamics, was crazy videos about like the Boston Dynamics Atlas doing all the parkour, the flips, all the crazy
Yeah,
stuff. But the idea of like, say, Tesla Optimus coming out and that actually being in people's homes and doing basic chores, Figure AI is another one. We're actually starting to see like real competition heating up in the humanoid robot space that's being commercialized. It's not just in a lab. Like I say, in a lab is fine. It's still very freaking
yeah.
hard. I don't want to undersell the work that's gone in there, but it's fine. It's controlled. Things go wrong and you don't see it. But when you feel comfortable enough to commercialize it and put it into someone's home, that is a very different. That means, there is less faults than 1 in a million, which is crazy to think of, that these things are now capable to work on these very dynamic environments, and the company feels comfortable that nothing's going to go wrong.
Yeah, it's interesting you mentioned versus in the lab. Like I saw a video going around. I'm not sure how spurious it is or whatever, but it was of one of these humanoid robots that was kind of in a lab. They were, didn't know if you saw this video, and they were testing it, and there was some malfunction, and it started spinning its arms in like an attack motion almost. I mean, I think it's people try to spin it like the robots become self-aware and it's trying to kill you, but actually it's probably just a mechanical malfunction. But yeah, that's the kind of thing we don't see often, and it was leaked from one of these labs. But yeah, I mean, were you telling me about, in terms of how far this stuff has gone, was there not a Tesla event last year that was fully robotic? And then I think there might have been some hoodwinking going on in reality, right? I think it was like people were saying there might have been humans controlling it. But the point being, we're at that stage now where companies are trying to showcase that they've got humanoid robots that can do stuff at least.
Yeah, 100%. And I think, like I say, there are many different types of robots being pushed out there. Autonomous drones, we talk about humanoid, all these kind of bipedal and quadrupedal robots. And maybe even things that people don't often consider robots, like exoskeletons is another big thing, both for like, again, military applications, as there always is, but also for healthcare. And you can imagine that being used in construction. Okay, Jack, we're about 40 minutes in, so I think we should maybe cut this down and pause this first parter. This is obviously, we've been putting this off for a while, so I think this might be our 3-part series, and maybe we can break it down here. So in this episode so far, we've covered how robotics has evolved from ancient myths and mechanical inventions to sci-fi influences like Asimov. And then we even went into the real world rise of factory arms and the early push into more dynamic environments. So I think we cut this first part of this 3-part series, and in the next part, we'll talk about, what actually makes a robot. What are some of the core components like sensors, the brains, motors, and software? And then eventually we'll explore how these robots are being used today. And maybe in the third part, hopefully we'll touch on what's going to happen in the future and give some predictions on this. But yeah, for those still listening, thank you for listening wherever you may be. And join us next time in part 2 of this robotics series to untangle a little more of Web3.